I'm like, you can try, it's totally fine. I mean, I can't prove that I'm right. All I can do is talk about what I've seen over 20 years of teaching this stuff. I mean, it's what statistics is constant observation and constant displaying of information. But at the end of the article, the author said, yes, it appears that you're going to get heads about 50.2% of the time and 49.8% of the time you get tails, which is slightly different than 50-50, right? And the students were so excited, like, we're going to prove we're all wrong. I'm like, okay, did you read the whole article? Because they sent the article to me. I said, did you read the whole article? And they say, what do you mean? It says in the headline that it's not 50-50 for a little bit heads. I'm like, did you read the whole article? Well, no. Because in the last paragraph, the authors admit that for those flipping a coin by hand, any advantage the machine gives is nullified because your hand is not that machine. Which means that all those little tiny variables that go into flipping a coin, the bouncing off the desk that I heard, some of you hit the book and just, there's all these differences, right? So because of all those different variables that are not, I mean, how many of you carry a flipper in your pocket? With a coin? Nobody does that. You take the coin flip like this on your hand. So the authors admitted at the end, yes, this is a very, very scientific paper, and it's pretty much meaningless in the real world. It's like, yes, that's my point. You need to read the whole damn thing next time you read an article. And if I can impress nothing else on you guys after this class, is to do just that. Read exactly the entire articles, because it's amazing sometimes. Headlines in the news will give exactly the title of an article, and if you dig into the article, you realize the truth lies somewhere else. Or at least is nowhere near as clear-cut as they might make you want to think it is. Yes?
Is there any difference, you know how people flip a coin and then they flip it over?
That should not be a difference. No.
Flipping it and having it land on the
So
ground?
the question is this versus letting it hit.
Yeah.
The only difference I've seen, and we'll test this in Math 244, those of you that take the class with me, is if you take the penny and spin it and let it fall on its own on a perfectly flat surface. Well, not that. But if it's allowed to come to a rest while spinning, that is different.
Huh.
That's different. I think there's a scientific reason behind it. And I would do it in this class, but we don't have the time to develop the math behind that, because you need to develop something called a margin of error, which we don't have time to do in this class, which is fine. But anybody taking 244? Yes, we'll do it then for sure. Super fun. One of the first things we do in 244. Because it's counterintuitive. You'd think it wouldn't make any difference. Flip, spin, whatever. It's a big difference. With a flip, you're interrupting physics. Whether the ground's interrupting or whether your hand is. But if you let that thing spin itself out, it's physics. There's no interruption. It's actually somewhat predictable. Pretty cool, actually. Pretty cool results. Anyway, let's collect data, then take 5. So how many of you that flipped coins 10 times got absolutely no heads? Nobody. Anybody get 1 heads and 9 tails? 2 heads, 8 tails? Yeah, good. 3 heads, 2, 3, 7. 4 heads, half and half. We had half and half, right? Yeah. 1, 2, look at that.
And it was in a pattern. I got 3 heads, 2 tails, 2 heads, 2 tails.
Wait, say that again. Oh, 3 heads, 2 tails, 2. Oh, that's kind of cool. As my son calls it, a pattern.
2 heads.
Pattern.
A pattern. I love that. It's a 3-syllable word. 6. 6. 7. 8. 9. 10. Okay. Let's take 5. Come back, average our results. And we'll give you your first statistics lesson with a probability lesson. First statistics lesson with probability lesson. You grab your TIs, have them ready to go because they're going to be fun.